have una row 6 standard 6-sided dice simultaneously and calculate the product of the 6 numbers obtained. What is the probability that a product is divisible by 4? For this one, you can probably realize that it will be easier to find 1 minus the probability of unwanted, which is 1 minus the probability of the numbers of the product being not divisible by 4. So case 1 will be all odd. So if it's all odd, then this will give us 3 over 6 to the 6th power, gives us 1 over 64. And case 2, when we have 1, 2, or 6, and 5 odds. And this one, we have to first choose 5 from 6 for the odds, and then multiply by 1/2 to the 5th power. And then we're going to multiply by 1/3, because we can have 2 over 6 and out of the 6 possible choices. And this gives 2 over 32 is equal to 1 over 16. So now we don't have any other cases, so the probability that we desired is going to be equal to 1 minus 1 over 64 minus 1 over 16, give us 59 over 64. And this gives us answer choice C. Sum of all possible divisors of n is divided by n as shown. What is f of 768 minus f of 384? So first, if we want to find the sum of the positive divisors, first we have to find the prime factorization. 768 is equal to 256 times 3, which is equal to 2 to the 8th power times 3. And 384 is equal to 768 divided by 2, which is 2 to the 7 times 3. And then we want to find the quotient when divided by n. So f of 768 is going to be, so first you see that we can first try to find the sum to 8, like the 2 part. And to 8th, you can have 2 to the 0. And you can also have 2 to the 1s. And then dot dot dot, and until 2 to the 8th. And therefore the sum is going to be 2 to the 9 minus 1. So f of 768 is going to be equal to 2 to the 9 minus 1. And then multiply by 3, we can have 3 to the 0 or 3 to the 1. So, and then f of 384 by the similar logic is going to be equal to 2 to the 8 minus 1 times 4, because 3 to the 0 plus 3 to the 1 is equal to 4. So therefore, now we can try to calculate f of 768 minus f of 384. So equal to, we can make everything in terms of 768, and f of 768 gives 511 times 4, and then minus 200. Let me extend this line over here, and then minus 255 times 8. So this, check it out. This is equal to 4 over 768, which is equal to 1 over 192, and this gives us the answer choice B. equals 2 pi over 11. What's the value of this mass? So for this problem, an important observation is 11c is equal to 2 pi. That's pretty basic. And also, we have sine of alpha plus 2 pi is equal to sine of alpha. And this actually makes a lot of sense because you're basically doing the same angle with respect to the unit circle. And also, we have sine of 2 pi minus alpha, and that gives us negative sine alpha. So these are the two identities that you have to keep in mind, and we see that a lot of cancellations are going to be taking place in this expression. That seems to be really scary. So first, we see that these two cancels out to be 1, right? Because by our first identity, sine of 15c is equal to sine of 4c plus alpha. Furthermore, 12c and c can also cancel out in the same way. But what about next? Next, we have to use the second identity, which sine of 2 pi minus alpha is equal to negative sine of alpha. So these two cancels out, but we have a negative 1 left over here. And for these two, it perfectly cancels out to be 1, 1. And sine of 9c and sine of 2c cancels out to be negative 1. So multiply to negative 1 gives us 1. And this yields the answer choice, E. Their polynomial with real coefficient having degrees 2, 3, and 6 respectively, and constant terms 1, 2, and 3. Let n be the number of distinct complex numbers satisfying the equation, and what's the minimum possible value of n? So for this one, we're given the condition that n also P of z times Q of z is equal to R of z. So first we see the degree different, and we know that, and also 1, 2, and 3, we know that 0 can just be not considered. So now we want to find like the minimum case, and we can actually let R of z be like any polynomial, right? Because P of z times Q of z, the constant term is going to be any 1. So this one will end in 2, and this one will end in 3. So if we subtract, then R of z minus P of z times Q of z, and then equals to blah blah plus 1, and that's equal to 0. So what is this mass? So this mass, since we can let R of z be any polynomial, right? So then we can just optimize it. We just let it be z to the z plus 1 to the 6th power, or even z minus 1 to the 6th power, because we can let it be like any polynomial. So in this case, if you have z plus 1 to the 6th power equal to 0, then z can only be negative 1, giving us only one distinct complex number z, which is giving us answer choice. Each side and 6 are stacked on top of each other. The middle sheet is rotated clockwise 30 degrees about the center, and the top sheet is rotated clockwise 60 degrees about the center, resulting in a 24-sided polygon shown in the figure below. The area of this polygon can be expressed in the form of a minus b times the square root of c, where a, b, and c are positive integers, and c is not divisible by the square of any prime, which means that c doesn't contain any divisor that is a square. What is a plus b plus c? So first we have to understand what does the rotation thing mean. So we connect one of vertex and the other one that's being rotated and connect it to the center. The condition that is rotated 30 degrees basically means that the middle angle created, alpha, is equal to 30 degrees. Well, when we see 30 degrees, we immediately have an idea of creating some 30, 60, 90 triangles. Or using the condition of 30 degrees, because 30 degrees is a special triangle on the unit circle. Therefore, also we have, when we connect this line, then we also have another alpha. So you can see that if we connect from all vertices of the of the polygons to the center, we will be able to create 12 identical figures. And the figure looks like airplane, right? So this is the shape, and we know that this angle created is 30 degrees. And what is the two sides? What is the two longer sides? Well, check this out. Longer side is basically half of the diagonal of the square, which, since the length is 6, then that length desired is 3 times the square root of 2. So now we can see that we're dealing with this shape. We can try to complete this shape into a triangle that we know. An isosceles triangle with two sides 32, 32, and the middle angle 30 degrees. And we have subtracted by the little triangle over here, which is 1/3 of an equilateral triangle. So what is S1? So S1 is basically the area of the outside triangle. Well, S1, we can use the area formula of 1/2 times A times B times sine C, which is 1/2 times 3 root 2 square times sine of 30 degrees, which is 1/2, gives us 9/2. How about the green area? The green area, something that we have to memorize is that the area of an equilateral triangle with side as S is equal to x squared times the square root of 3/4. So you can see that we do not really have to find the side length, find the red length, but we just only find the square of it and then multiply by square root 3/4. But remember, this is 1/3 of the equilateral triangle, so we have to multiply by 1/3 again, which gives us s squared root 3/12. So just want to find s. Well, remember, when we have two sides, right? 3 root 2, 3 root 2, and we have a middle angle 30 degrees, and want to find the third side. This immediately jumps out to our head, the law of cosines. Law of cosines. Let me erase all of these. The law of cosines. So basically, let this be z. Z squared is equal to 2 times 18, because 18 is 3 times square root of 2 squared, and then times 1 minus the cosine value of 30 degrees, which is square root of 3/2. So which is equal to 36 minus 18 times the square root of 3. And now we want to multiply by square root of 3/12, because that is the area of 1/3 of an equilateral triangle, and this gives us 3 root 3 minus 9/2. So subtract from S1, we get the area. The area is equal to 9/2 minus 3 root 3 minus 9/2, which is equal to 9 minus 3 root 3. But don't forget that we have to multiply the entire thing by 12, because we're find the total area of the 12 identical figures like that. Therefore, multiplying by 12 equal to 108 minus 36 times the square root of 3, and want to find A plus B plus C. Therefore, our answer is going to be equal to 108 plus 36 plus 3, giving us 147 as our answer choice E.